In the last section, we discussed the dissolution process. When dissolved in water, some can conduct electricity, and they are called electrolytes. In this section, we discuss electrolytes. First, we'll give the definition and a few examples of electrolytes. Second, we'll discuss the physical and chemical changes during the dissolution of ionic and covalent electrolytes. Third, we'll discuss one important factor that can affect the electrolyte strength. The electrolyte strength can determine the capability of an electrolyte to conduct electricity when dissolved in water. And the important factor is the solute and solvent attractive forces. Non-electrolytes do not produce ions when dissolved in water. Here is one example, the ethanol solution in water. When dissolved in water, ethanol molecules remain as molecules and then do not contain dissolved ions and then do not conduct electricity. So that's the reason here the light is off. In contrast, when dissolved in water, potassium chloride can dissociate 100% into potassium ion and chloride ions. Here's the equation: potassium solid. This is aqueous form of chloride ion, potassium ion, and aqueous form of chloride ion. So you see in the solution, there are both potassium ions and chloride ions. Then the solution can conduct electricity. So that's the reason why the light is on. Potassium chloride is a ionic solid, is ionic compound. Before dissolution, the potassium ion and chloride ion already exist in the solid. And after dissolution, potassium ion and chloride ion exist in the solution, but still in the form of potassium ion and chloride ion. So there's no chemical change. The dissolution of potassium chloride in water is a physical change. Acetic acid is a weak electrolyte because its solution does not conduct electricity as well as the potassium chloride solution. That's the reason the light is on, but the light is not as strong as the light here. So the light intensity here is weaker. Its dissolution in water involves a chemical change. We'll come back to these 2 points in the following slide. The conductivity of an electrolyte solution is related to the strength of the electrolyte. Solutions of electrolyte contain ions that can conduct electricity. The more ions in the solution, the stronger the conductivity of the electrolyte solution. Potassium chloride is a strong electrolyte. The reason is because when dissolved in water, 100% or nearly 100% of the dissolved potassium chloride can dissociate to form potassium ions and chloride ions. This single direction arrow means this dissociation reaction can proceed 100% or nearly 100%. In contrast, acetic acid is a weak electrolyte. The reason is because only a relatively small fraction of the dissolved acetic acid can generate ions, acetate ions and hydronium ions. Here, the starting material is acetic acid, And then in the starting materials, acetic acid molecules are present in acetic acid. Then, from this reaction, these two kinds of ions are generated. Here, it is a chemical reaction because the composition changed from molecules to ions. Besides, here, the dissolution reaction is represented by this arrow, while the backward reaction is represented by the upper arrow. This arrow is shorter than the upper arrow. It means only a relatively small fraction of acetic acid can proceed this direction. Only a small percentage can go this direction, can generate ions. Potassium chloride is a strong electrolyte. Why is that? Here's why. When dissolved in water, chloride ions are surrounded by partially positive charged hydrogen atoms. These are all partially charged hydrogen atoms. At the same time, potassium ions are surrounded by negatively charged oxygen atoms from water molecules. Such electrostatic attraction between an ion and a molecule, here is one ion and here's one molecule, is called ion dipole attraction. Strong ion dipole attraction leads to not only the dissolution of potassium chloride, as we discussed previously, but also leads to the dissociation of potassium chloride. This dissociation leads to the formation of potassium ion and chloride ion. Under most conditions, soluble ionic compounds are strong electrolyte. Some covalent compounds can also be electrolytes because they chemically react with water to produce ions. For example, hydrogen chloride is a strong acid. When dissolved in water, it reacts with water completely. Here, this arrow represents the complete reaction. The products are hydronium ions and chloride ions. Here, they are all ions inside. They are all ions inside, positive and negative ions. There's no HCl molecule inside. In contrast, acetic acid solution has a much lower conductivity. The reason is because only a small fraction of acetic acid can dissociate to form acetate ions and hydronium ions. Generally, strong acids are strong electrolytes. Weak acids are weak electrolytes.